Look at that. We're live with all the fine folks on the internet. Welcome.
All right.
Hello, Internet.
Yeah. Hey, Internet.
Internet, we're here. It's been so long since we've seen you.
Yes, it feels like we were just here.
It's true.
Internet, obviously, you can see our awesome two special guests, Robert Halleck, Frank Azor. You are familiar with them. They are fantastic people over at AMD. I just want to give you a quick warning. Robert has to get out of here at the top of the hour. He's got important stuff to talk about. Frank, we're going to keep for a little bit longer, so we're going to keep it going as fast as we can. So not the usual kind of Gordon wasting everybody's time stuff. But let me know when you're ready.
Hit it.
Do it.
All right, 1 second. All right, we got our coffee ready. All right, cool. Looks like
Yeah, Yeti cup, special Yeti cup. That was
it's a
Christmas
short
gift.
one. I don't think I've seen the short one before.
Yeah,
Nice.
out of Austin. They make a lot of good stuff down there.
There you go. Yeah, I don't know what else. Barbecue. That's what you're talking about, right?
Oh, the barbecue, yes.
Maybe some processors too. Just a few things.
Oh yeah.
Oh, okay. Oh, yeah, that's
Good
what
people.
So this isn't the barbecue cast. This is the processor cast. Got it. All right.
Suck it. BBQ is next.
Oh man. All right, cool. Then, yep, I'm ready to go whenever you are, Gordon.
In this episode of The Full Nerd, AMD talks CES. Welcome to a special episode of The Full Nerd. I'm your host, Gordon Maung, with co-host Brad Charkis.
Hello, Internet.
And very special guests, Frank Azor
Hello, everyone.
and Robert Halleck.
Hey, what's up, y'all?
Both of them, of course, with AMD, and Adam Patrick Murray is, of course, controlling the vertical and horizontal.
It's we're here. We're live. CES has not destroyed us yet. Thank you to Robert and Frank for joining us. We're here to talk some announcements. There was some big news, right?
Yeah, we're very happy to
A
be
little,
here, guys.
yeah.
Thanks for having us.
Yeah,
Appreciate it.
and again, if you're catching the stream, he's going to pop out at the top of the hour. He's at the top of the hour. He has some important stuff to do. So I want to just get straight to it. My first question, Robert, obviously Ryzen 7 5800X3D, that's going to be your first Vcache part. AMD is touting it as the world's fastest gaming processor. Is it really going to be that?
I truly believe so. What we've seen from a characterization of gaming workloads is that modern PC games are making a ton of random requests to memory. They are memory latency sensitive more than any other category of sensitivity. There's, of course, frequency sensitivity and core count sensitivity as well, but overwhelmingly, fast memory access is what's making the performance difference for a lot of these modern PC games, especially ones that are still developed on DirectX 9 or developed to run on a wide range of hardware like esports titles. So when you think about those fast memory accesses, and they happen so randomly because a game cannot predict what the user is doing. If they want a 360 no scope, well, that can't be predicted. The textures, the models, the sounds, the animations, they just have to be there or get fetched. And so if you can make a local pool of memory substantially larger than any other CPU that's ever been developed, that memory access doesn't have to go to RAM anymore. It goes to the CPU instead. And it's making a massive difference in the performance of PC games. We're seeing uplifts of 20, 30, 40% in PC titles versus the non-3D stacked cache version of essentially the same CPU. So yes, we're absolutely convinced we do have the fastest gaming chip out there. And we built it with 8 cores because people tell us they just want a game. They want the best CPU for gaming. So 8 cores, ton of cache. It's a match made in heaven. It's a great chip.
Of course, that was the reaction from the people who like to pay for Ryzen 9 are like, wait, I want Vcache 2 on my 5900X and 5950X. why not now? And obviously you can't talk about future products, but people are like, I want this. Can we get it, please?
I think what you're seeing is on the business side, or AMD maturing as a company side, is we can start to explore, I guess you could call it out of band or originally not roadmapped products that may be more specialized than the one size fits all Ryzen products that people have seen before. We can offer a parallel opportunity, an alternative path for people. And the number one piece of feedback we get for our box processor business is, I just want to play a game. And most games are designed around 6 or 8 cores, because that's where the consoles are targeted as well. So there's a lot of synergy for developers there. And you put a big block of cache on top of that, and you run it around 4.5 gigahertz, and bingo bango, you've got an extremely fast, predictable, consistent gaming CPU. And so, that may not be the core count for everyone, but it's probably the core count for most people.
Makes sense. And the Ryzen 50, for people who don't know, Vcache, of course, is a stack cache that's going on top of the existing Ryzen 5800X die, essentially. I've noticed, your clocks drop a little bit. I think you lose about 200, 300 megahertz going from a non-stack part to the Vcache stack part. Is it because of the heat or just another binning issue?
It's really the performance targeting of the part. As we were modeling what these games are sensitive to, it's not frequency. And I want to be very clear about this, because this is a nuanced topic and this could easily be spun into a very bizarre headline. Frequency is important. But every processor, every game is always a series of trade-offs, bottleneck mitigation. And in our architecture, when you're in the range of 4.5 to 5 gig, 4 or 5 is enough when you put a ton of memory on top. You're not limited by frequency anymore. You're not giving anything up to target that frequency. It's the performance limiters or the performance accelerators move elsewhere in the architecture. So we can dial back on the frequency a bit, ease up on the thermals, make it easier to cool, and then drop in a big extra blob of cache on top, which is more transistor density, more thermal density. And so that's a trade-off that was very easy for us to make.
Yeah, I think the key thing, Robert, is the TDP of this part is still 105 watts, right?
That's right.
So
that's right.
There's some give and take that has to happen in order for us to fit within that envelope. And it is still overclockable, right?
Is unlocked. Yeah. Is it? And and I think that is a good point to make, is everybody sort of assumes you always want to take everything to 11 on every single feature, but
sure,
there's legitimate engineering, logistics, and business reasons for not doing that for everything. So can we, there's been some talk that adding the Vcache onto these parts is a significant cost adder. You obviously can't talk about what the pricing is ahead of time. I'm going to guess it's going to be more. Do you want to give us any kind of hint to soften the blow yet, or just simply don't want to say anything because you don't want to get to work and find all your stuff in a box and security waiting for you?
Yeah, and my seniors at AMD. No, the truth is, I don't know the price yet, and I think collectively as a company we don't know the price yet. What I can say or do know is there's lots of competing offerings out there within our own stack and from other blue companies, and we're very sensitive to the price performance of a part. That's something we model early and often based on a variety of different workloads. So we're not, we're not ignorant to what's going on for pricing out there in the market. And when we make the final decision, whatever that ends up being, we want to come in on the right side of history.
I was wondering just about cache in general. It seems like cache is a big focus for AMD around. You guys had Game Cache. Now we have these 3D stack chips. Infinity Cache is a big deal for the RDNA 2 GPUs. I was just kind of wondering what made you guys start moving in that direction? Like
Sure.
all of a sudden it's popping up everywhere for you guys.
Everywhere. Well, it's one part engineering and one part, frankly, one part marketing. On the engineering side, what's true is that so many games now are moving to this very latency sensitive design. And a great way to hide latency or work around it is to simply make a memory pool larger. You've eliminated the time that the GPU has to go to frame buffer or the CPU has to go to the motherboard's RAM, and that can be a huge accelerator. So that's the engineering reason for it. And the marketing reason for it is that people have started to realize that there are non-frequency and non-core count reasons that certain processors or certain GPUs are faster than another. So the user consciousness has widened. So making sure we're continuing to invest in that so people understand from just a conversational perspective that things other than frequency or cores can matter a lot, matter more than perhaps any other metric. That's an important effort for us as well to make sure people understand, what's going on architecturally, both in software and in graphics or processors.
If I can piggyback off of the cache speak, there's a couple good questions from the chat. Ryan Dietz, I think I'm pronouncing that right, asks, how much of a latency penalty is there with the 3D cache versus normal L3 cache?
It's a couple nanoseconds. Anytime you make, that's a great question, because anytime you make an L3 cache larger, it does add slightly more seek time to find the first bit of memory. And that's true of any memory type. It could be RAM, it could be GPU memory, cache, whatever. So yes, L3 cache latency does go up a few nanoseconds, but net, the penalty, if you will, of that is vastly outweighed by the benefit of skipping RAM altogether very often.
Okay. The next question is from LB. Why not use 3D cache for L3 only and use 2D cache to expand the L2 cache?
It comes down to the architecture of the chip. So the reason why we want to do an L3 cache is because that's shared amongst all the cores. You can never guarantee which core is going to, or let me take it from an application point of view. I'm an executable. I've spawned up X number of threads to run my game, maybe physics, audio, animation, whatever. I, as a CPU designer, cannot guarantee what core that workload will land on, or that thread will land on. So if I put on L3 cache, more of that cache is shared amongst all the cores evenly within a die. So now it doesn't really matter what core that particular thread lands on. I have that fast access all the time. Geometrically, it also makes sense because on the Zen architecture, our L3 cache is right in the middle. You've got 4 cores on the left, big block of L3 cache, and then 4 cores on the right. So it's easy to put that large chunk of cache right in the middle, stacked vertically. So it makes sense from a geometric and design perspective as well.
So I have a question, because, a lot of it is very much about marketing and the value of seeing world's best gaming, processor,
Sure.
check mark. That's a big deal. Is that also what kind of drives the whole 5 gigahertz thing? Because everybody's got 5 gigahertz parts. Everyone seems to have chips coming that can also run at above 5 gigahertz on all cores now. All the claims. Which is more important, 5 gigahertz or world's best gaming CPU?
Probably world's best. This is an interesting, I could spend quite a while on this. The lightning round version is, we've done a lot of consumer research on what is sticky with people. When they see a letter or a number or a spec on the box, what moves the needle and what doesn't. Big round whole numbers like 40, 45, 50, that moves the needle quite a lot in consumer preference. But something like 5.1, 5.2 barely registers. on the Richter scale. But then above that, it's use case relevance. You know, you've moved from spec to, is this good for me and what I want to do? And so if you're looking for the best CAD CPU, best gaming, best software development, best compiling, that carries even more weight than a spec. And I think we've also seen, maybe over the last 2 or 3 years in particular, a decline in general market focus on frequency. I think people are realizing that, for example, Ryzen can come to the table at 4.6 or 4.7 and credibly beat a CPU that might be running at 5.1, 5.2. And that's a 500 to 600 megahertz spread. How do you reconcile that? And the only answer is that maybe frequency doesn't always matter.
Right. And then I don't want to keep hogging all the questions here.
Go ahead.
So it is interesting because, you know, we have Ryzen 7 5800 X3D. I mean, honestly, for gaming sounds awesome, but it feels like the response from Intel is also, it's sort of taking a page out of your book. I hate to use that term, but you know, AMD has been beating Intel's brain in for 3 or 4 years now with core count, thread count. Now they have Alder Lake with their sort of, you know, performance core, E-cores, but they have a real thread count advantage, and they're basically beating AMD at the Cinebench game, frankly, which is a good way to look at it, because that's what people care about. Any concerns that, like, people go like, oh my God, I get way more Cinebenches on the Alder Lake part going forward.
You know, we as vendors have used Cinebench for a long time, simply because it's an all right indicator that runs in a minute or two of single thread performance. But I'll take Zen 3 in particular as a good example of why that can be deceptive. If we had based the IPC increase of Zen 2 to Zen 3 on Cinebench only, it would have been 9%. The number would have been 9%. But we know that the IPC increase across like 25 workloads was an average more like 19 or 20%. And games were 26 to 30%. And it's because IPC, instructions per cycle, really varies depending on the workload. And so it's important to take a more holistic view of what the core is doing at a fixed frequency than just Cinebench. It's not that Cinebench doesn't matter or isn't important, but it can give a very limited perspective into what's going on. And it can leave a lot on the table, or it can it may not inform you of everything. So Cinebench will continue to run it, continue to share those numbers, but taking a wider view of what's going on, as you saw in Zen 2 and Zen 3 from us, is going to be important as well.
I was actually hoping you would both just sort of trade positions, and Intel would say, oh, Cinebench is the best thing, you should all be running it. And AMD would say, oh, no, don't run Cinebench. You shouldn't. But no, I
think we want to be realistic. You know, the fundamental engineering truth of benchmarks is that you have to run a bunch of them to get a complete picture. And especially when it comes to performance of one core. Because you could have things that are more float sensitive, or integer sensitive, or memory sensitive, frequency sensitive. There's like so many variables that one benchmark cannot do it all. And so taking a more expansive view is important, and Cinebench is one of many.
Cool.
I have a question.
Sure.
So your chips are going to have Microsoft Pluton in them now going forward. You're all going to have the first chips after working with an Xbox. I don't think a lot of people really understand what Microsoft Pluton is. So could you give a high level view of that and explain some of the benefits why you guys are making this change?
Sure. So to start at the physical level, for many years in the Zen era, we've had an on-chip security coprocessor called the AMD Secure Processor. That is a chip within a chip for us. Pluton is also a chip within a chip. So now we have two of them inside the Ryzen 6000 series. Pluton is designed It's a bit arcane, but the simplest way to explain it is that it provides new attack vector mitigation as people move their data and their workloads into the cloud. There are certain physical access or software exploits that can be leveraged against the system to gain access to those cloud services, those cloud data that you need special security handling for, and that's what Pluton addresses. But going the next level down to explain, what are those mitigations, what are those vectors, that's like collegiate thesis level type stuff. But that's the basics: cloud security.
Are we going to see a little more transparency on what Pluton does? Because a lot of the pushback I've seen from people is they just don't like things they can't control or don't know what they are. But
sure,
I would argue, of course, if you gave it all away, then that just makes it open to more attack vectors. But I don't know how you sort of balance that. But I guess people would want to know, hopefully, more about what Pluton does exactly.
And we will. Coming into the January-February timeframe, we're working on a ton more information around the Ryzen 6000 series. We have by no means said everything there is to say. We want to go deeper on the architecture, the new power management features, the new security features. And when that time rolls around, which is only a couple weeks away, we'll go into what kind of attack vectors we're talking about, how Pluton functions, that kind of stuff. That's definitely in the cards. We know people are curious.
Okay, so we talked about Vcache, the improvement to games. That's obviously the focus with these stack chips. Have you guys seen any improvements? Obviously, you having some like non-gaming applications. What is there any particular areas that you think the extra Vcache and the 5800X 3D makes a substantial difference?
I'll level with you guys. In the consumer space, it's games. These more traditional productivity workloads or office type workloads. Office is like 1 core performance, 2 cores performance. Productivity stuff is just how many cores do you have, a little bit of frequency sensitivity on top. But those workloads are super predictable, which means they're not memory sensitive. They're not cache sensitive. So we're not seeing outsized gains in the consumer space for larger cache. This is a dyed in the wool gaming part.
And I know you said this is just sort of like the best, it makes them perfect fit for Vcache. I do wonder though on Vcache, what would happen if you had a 2CCD part? I mean, because now you have 2 separate L3s in a way.
Sure.
Does that make a difference or in your internal modeling, I guess?
You might actually lose a little performance because cache works best when it's symmetric. That is, sometimes contents are duplicated from cache A to cache B across dies, for example. So let's say you had an asymmetric configuration where one die has a cache and the other doesn't. You might have a thread over on die B that now has to fetch across to die A because die A has that larger cache pool and has data that die B doesn't. So that's a cost in time. That is an added latency. We're trying to remove latency. And then even then, let's say they're both symmetrical and you have 2 dies. Well, that could lead to a scenario where the data in each cache, even though they're the same size, they don't have the same data. And now you're exchanging back and forth. And that too is a latency difference. So, that's kind of a pro and con of going to multiple dies with mixed cache sizes. And that's one of the reasons we stay laser focused on 8 cores for this product.
Follow-up question from the chat. Michael Sawyer asks, could you put the cache over the I/O die instead of the chiplets?
You could, but you wouldn't want to, because that adds physical wire distance to the cache access. You want that cache right there, local, running next to the cores. For the fastest possible access time. And if you don't do that, then you're just taking away from the benefit of 3D stack caching.
Okay. And then we also had one second, a $5 super chat. Thank you so much from Byron Goodman. Said,
Nice.
increasing cache doesn't necessarily increase performance. Compilers need to be tuned for locality. Are you working with developers to tune this?
In this case, because it's a single die product and all cores simply have more cache available, we're not, there are no topology related cache locality issues. It's simply a larger cache pool, and you get very nice organic innate benefits from that is transparent to both the OS and the software running on it.
So short answer, no need to recompile to get the performance advantage.
No.
Well, go ahead.
No, I was just saying, you don't need to.
I was gonna, because honestly, I could keep talking about, the X3D part for the next hour, but I want to ask about Ryzen 6000, because to me, I know all the desktop people want to talk about the Vcache part, but Ryzen 6000 is probably more significant for AMD in a lot of ways because laptops move a lot of product. What can we expect out of Ryzen 6000? I mean, it looks like a pretty decent increase in performance. I mean, you were saying, I think your slides showed it as 28% on the U parts.
That's right. So we've done something interesting with the 6000 series, and it all comes down to power management. We were kind of blessed with this Zen design. I think in general, Zen internally is not just the code name of a core. It's also a design philosophy for us to make an x86 microarchitecture that is physically more compact than other designs and is capable of scaling to lower power and higher performance within that one core than competing designs. So we can kind of have our cake and eat it too. And so what we did with the 6000 series is we really indexed on that thinking. We added 50 new power management, new or improved power management to the core itself. So it's just Zen 3 Plus. Then we've added new power management features to the Infinity Fabric, memory controllers, display controllers, Uncore. We've added new voltage planes, new firmware. And when you have that much more control over your power, it also means you have that much more control over your performance. So within that ultra thin space, the U series, we can now take the same Z height, the same battery life, and go up to 28 watts now. And that'll give you like 30% more CPU compute, twice as much graphics performance, 10 to 15% more single thread performance. And we're talking same Z height, same battery life, same acoustics, same thermals. We can just squeeze so much more performance out of that SoC thanks to these new power management features and, net increase on battery life too. So it's a huge development for us in the performance space. It's proof that, you can get pretty huge gains without making, particular IPC improvements. Sometimes it can come from power. It's just come from better power management.
And there was no 28 watt U part previously. It's a 15 watt TTP, and that's sort of I've heard people sort of accuse AMD as like, oh, you're this is a sleight of hand because you're comparing a 28 watt 6800U versus a 15 watt 5800U. But
yeah,
that's a really good point. It's like you couldn't push the previous part to the performance levels.
You just couldn't do it. You couldn't do it, and that's an achievement we're proud of. We want to compare that 28 watt to 15 because last year 15 was the best you could do. There were vendors that did push that SoC a little harder into the 20 or 22 watt range, but the design was not optimized at those points. So you were increasing power, but getting diminishing returns in performance. But now we can go all the way to 28 and we've characterized it, built it, modeled it, and we get scaling all the way up. And so you can get a laptop that's as small as or smaller than last year with more CPU performance, more graphics performance, more battery life, better acoustics, better thermals. That's a huge technical achievement. And that's what we set out to do.
I have a discussion point from Dr. Ian Cuttress of Tech Potato, friend of the show.
Ian.
He says 28 watt versus 15 watt mobile benchmarking. Discuss.
Well, the way we do it is we have either open air test benches in a thermal chamber, calibrated to a very specific temperature that would be like the inside of a chassis, or we have a test mule built to represent the sort of the average of the ultra thin category for the year. And we just bench all things being equal. We set up the power envelopes and the thermal designs exactly as they would be in a shipping chassis for a customer, and load the firmware image, load the OS, install the drivers, and off to the races. I would try to keep it pretty simple.
Although, it really does. I mean, people love the chip nerd discussions, on Reddit, you get into it, but it really does. There's always that odd disconnect because you don't buy a CPU and put it in your laptop. You buy a whole laptop. It's a whole platform. It looks like you have, I think there were two AMD Advantage, maybe just one AMD original Advantage system, but now you're saying there's going to be 20. What was the big reason for the adoption this year?
I think for a longer period of time now, there's been a lot of confidence in Ryzen CPUs, but it really wasn't even until CES 2020 that we started to see some mass adoption of Ryzen CPUs in gaming systems. And around that time, we were introducing RDNA 1. And I think there was a little bit less confidence in RDNA than there was even with Ryzen, because Ryzen was further along in the journey, especially with the inroads that we had made on the desktop side with that 3000 launch. So there was initial hesitation from OEMs, very honestly, to rapidly adopt Radeon-based notebooks, because we hadn't even been in notebooks in such a long time with the Radeon brand. So what we saw was in that first year, we had the Dell G5 15-inch come out, and that was kind of like the first mainstream gaming A+A Ryzen and Radeon system that came to market. And then this past year in 2021, that one system turned into 7. We had MSI launch several SKUs with us. We had Lenovo launch, HP, and Asus ROG launched several systems with us. And they went so well. The experiences from customers, the feedback, not that they were perfect. We had a couple hiccups here and there. We're very aware of them. And we've tried to resolve every problem since then with our OEM partners. But the response was so well received. The reviews were so good on the systems that every one of those OEMs expanded their portfolio with us in 2022, and more OEMs have jumped on. And now they see that Ryzen and Radeon-based notebooks, they can succeed in market. Radeon is competing effectively on desktop and on notebook, and they're leaning in a lot more with us now. So you'll be able to find well over 20 new Advantage designs in market, kind of sprinkling out throughout the year here, with the first ones hitting in February.
I'm going to have a lot more questions about smart chips and laptops and whatnot. But before Robert leaves, I just want to ask, so the pins on the back of AMD CPUs are iconic, and you guys are going to be moving to LGA for, Ryzen 7000. I was wondering if you could just talk about why you decided to make that change, because like I said, they're iconic.
Yeah. Well, choosing LGA versus PGA is, it feels contentious to the public if you look at the chatter online, but it really comes down to pin density. How many pins do you need on the bottom of the CPU to pin out the features that are in the chip? When you can do it with LGA, you just do it with LGA because you take on, or you do it with PGA, because you, the CPU manufacturer, can take on the complexity of pinning things out, and that complexity is not on the motherboards. You're not shifting the complexity to all the different motherboards in market. But when you reach a certain limit, maybe you're going to, I don't know, PCI Gen 5, DDR5, you've got more features. Well, you need more pins now. and PGA might not be the right choice anymore. So we are switching to LGA. I believe it's 1,718 pins, LGA 1718. And it's just density. You know, how much is in the chip and what do we need to put down on the board? We needed more pins.
But all the existing coolers are still going to be compatible, you said, right?
Exactly right. So a lot have been said about the shape of the CPU lid. And those cutouts are making room for capacitors, surface mounted capacitors that would have been on the underside of the CPU in a PGA equivalent part. But you need all the space you can get on the bottom of that chip. So we moved things up top and made those cutouts, and that allowed us to keep the same package size as AM4. It's not pin compatible, but the CPUs are the same length, width, height. And that allows us to maintain cooler compatibility with socket AM4.
And actually, I do have a question about the heat spreader. And for people who don't know, we're talking about the Zen 4 Reveal. It has those cutouts in it. Mm. A lot of people are like, are those actually, is it open access to the die? Am I going to fill that thing up with thermal paste and short things out? Or is it actually, is it sealed? There's not just simply access to the inside of the chip, I guess.
It's sealed, yeah. Yeah, you're not going to fill it up with thermal.
Well, those little grooves could fill up, get some nice little residue gunked up in there over time, though, right?
Hey, with a Q-tip and some rubbing alcohol, anything is possible.
There you go.
Yeah, that's no fun.
All right. So with Ryzen 6000, the move to RDNA 2 is obviously very exciting. Vega's been doing great for y'all in mobile space over the last few years, but the move to RDNA 2 looks great. And it requires so much more memory bandwidth that you guys also had to embrace DDR5 pretty much across the board, LP DDR5 as well. Those have been very supply constrained in the DIY market. Are you guys worried about supply constraints on that front in the OEM market?
Truth is, Brad, I have no idea. I don't deal with logistics or supply at AMD, so I couldn't say.
All right. Oh, I tried.
What I'd say is like anything that's brand new, especially in today's market, it takes a while for things to ramp up. There's no guarantees, and I'm not the last guy to talk about supply and availability, but we are seeing things ramp up quickly. People have been placing their orders for DDR5, securing their supply, their incoming supply. So it's going to ramp up. It's a ramp up period, like DDR4 was, like every new technology transition is. So I do expect that there's going to be some hiccups, but it is getting significantly better with every passing month. And most supply has been locked up, forecasted. Orders have been placed now over 6 months ago, over 9 months ago, and 2022 is going to be the year that it ramps.
I do have another supply question. Milind Veer gave us a 4-pound super chat. Thank you so much. Said it's hard to find Ryzen laptops last year. Is this trend going to continue on the laptop front?
Again, I'm not the best person to talk about availability of anything, and I won't take any bets on that. But what I'll tell you about last year is what I said a little bit earlier in answering Gordon's question or Brad's question. It was, very honestly, there was skepticism around Radeon-based laptops last year, and with good reason, right? We hadn't been in the category for a very long time. So even though those OEM partners partnered with us and they leaned in with us and we're extremely appreciative for it, I think all of us, we really didn't anticipate how successful the demand for these laptops was going to be. And the forecasts are higher this year. The supply is going to be higher, the availability, the quantity of models, the regional availability of them, retail and e-tail availability of them. We are exponentially increasing all of those plans, and there should be better availability. But, we haven't done this in so long. We haven't had Radeon high-performance gaming laptops in so long. To be very honest, we're not entirely sure how many of them we could sell yet. Our competitors have a run rate of a decade plus. And they kind of know, hey, if the market's going to go up 15, 20%, we're going to do X amount within that. There's a variance of kind of margin of error there. We don't have that history right now. So Until we build that, with yesterday or last year being the foundation of that, this year will give us more intelligence. We're not going to really know for sure how strong our supply availability is going to be on Radeon based laptops, but it's a good problem to have. We're very grateful for the support that the community has given us on these laptops, for giving Radeon a chance in laptops. We've upped the ante with everything we launched at CES. I mean, there's like a huge smorgasbord of SKUs now, from performance to efficient SKUs with the new Slimline. So we're doubling down on our investment. OEMs are doubling down with us. We're going to do everything we can. Trust me, we want to manufacture and supply you guys. The last thing we want to do is not have supply for the demand that's out there. But we're learning as we go along.
Can I ask a couple questions because we are getting close before Robert turns into a pumpkin. Clearly with Ryzen 6000, a lot has been done for power optimization. You're obviously getting way more performance out of it due to that. But I kind of look at the math of 14-core Alder Lake H and P series versus 8-core Ryzen 6000s. I can sort of see the math of who's going to win there, but I do wonder if the battle for 2022 might actually end up being battery life. They may give you they may do really, really well plugged into the wall, but can you give us any sense, like, is Ryzen 6000 just going to like wow us with battery life because of these efficiencies you built into it?
We believe that with our 6-nanometer process and the Zen 3 Plus core, we have a significant battery life advantage, particularly in ultra-thin laptops. And as far as consumer careabouts go, performance, battery life are like equal careabouts in that market. So I think it'll be a real dogfight on performance. I think we're gonna have a wonderful time in graphics performance. Battery life is going to be, I think, our domain, but it'll be an exciting 2022, a competitive 2022, but very, very confident in where our performance versus power is sitting on Zen 3 Plus.
So a lot of talk about battery life for Ryzen 6000 has revolved around the power optimizations in the Ryzen chips, obviously. But you guys are also moving to RDNA 2. Is that part of the equation as well? Does that factor into that?
Certainly. The RDNA 2, RDNA as a family scales incredibly well to low power, and so did Vega. The amount of performance we're able to extract out of each generation of Vega, as we move to 7-nanometer from the larger nodes, going down into the 15-watt TDP on APUs, RDNA is that times 1,000. RDNA scales so well to low power, so you can extract so much performance out of it at a lower average power than the previous architecture. So that helps as well dial in, exactly the right performance level for a given battery life. And there's, it's not just RDNA shrunk down and placed in the APU either. There's new sleep states and power management features for this implementation in particular that we'll talk about in the weeks ahead. And so we've really left no stone unturned here when it comes to power management inside the SoC.
Cool. I'm going to try to squeeze one last question in because I think we got 2 minutes for Robert has to go. Big move from Ryzen 5000 mobile to Ryzen 6000 is you're adopting PCIe 4. Wasn't in the original part. I'm kind of interested in the PCIe lane mix. You're basically it's 8 for the GPU Gen 4, and then you have 12 for storage and another plumbing. What was the reason for not giving full 16 lanes to the GPU for the H parts?
Oh man, that feels like a perennial question. The truth is that 8 lanes is more than enough for GPUs. Even the biggest, fastest, highest end, highest performance, when you're talking gaming, 8 lanes is enough, especially 8 lanes of Gen 4 or 16 lanes of Gen 3, which are equivalent. So when we think about balancing die size, cost, power consumption, complexity, performance, there's a very clear pull towards 8 lanes because it doesn't sacrifice anything in performance, but shrinks down the die size, shrinks down the power envelope, increases battery life, reduces complexity, reduces cost. That's a clear tip of the scales there.
And not just on the chip itself, but for the entire platform as
That's
well, right? The whole motherboard ends up being simpler. You don't have to route all those lanes. You get to save money. There's
point.
benefits for the entire solution. So it's one of those things where had you made that investment, you'd get no uplift for it, virtually no uplift. And ultimately, at the end of the day, all that cost trickles down to the end user. So they would have been paying for something that they wouldn't have benefited from.
And I just want to note that 8 lanes of Gen 4 is the equivalent of 16 lanes of Gen 3. So for people who don't know that math. So although I think that's it. It's the top of the hour. Robert has to go. We do get Frank for a few more minutes, though. So thanks for coming by, Robert.
Guys, always appreciate it. Love coming on the show. We should do it again for the 5 nanometer stuff coming later in the year. I think it'll be fun.
May 5th. I'm pushing May 5th. May 5th, 5 o'clock.
I'll give them all the
PCIe
details.
5.
Robert, don't worry. I'll give them all the details after you hang up.
Sounds great, man. Appreciate it, Frank. All right. Thanks, guys.
Thanks, Robert.
Thanks.
To start off with Frank, I do have a good question from Dr. Ian Cuttress. He asked this earlier. I'm sorry. It was for Robert, but
No, then
I read that
I don't
wrong.
think I can answer any of Ian's questions that were directed for.
Well,
Rob.
no, this is. But I think this might be one you can get to. Is there any work on web cameras sending high resolution images down the pipe and enhancing them? Can we also get an AMD version of RTX Voice?
So, the typical answer I have to give in these scenarios is we're not ready to announce any unannounced products that may or may not be in our plans. So I can't confirm or deny if we're working on anything like that. What I will share with you is clearly you probably pick up some echo in the background of me talking right now, and so does everybody else on the other end of every meeting that I have. And Robert's mic didn't sound that great either. So we clearly need a solution for AMD. So I'll say that. And then the other thing I'll say is the FSR algorithm, being a spatial algorithm, has given us a lot of opportunity. We've capitalized on some of that opportunity with Radeon Super Resolution that we introduced at CES. But there are other opportunities as well beyond just rendering and how we've implemented that algorithm in a rendering environment. And that could lend itself to image processing and improving image processing through upscaling. But all I could say is that it could lend itself to that at this time. I'm not ready to confirm or deny whether or not we're working on either of those two products.
Well, a friend of the show, VC Jester, gave us a $5 super chat. Thank you so much. Said, Frank, I'll buy you a new mic if you can get Lisa Sue on the show.
I actually have a pretty good mic. The issue is that I'm in this echo chamber of my office, which has no sound dampening, no carpet, no rug, nothing. It's just a big hollow den. So if you're willing to outfit my entire room with sound dampening material, then I'll make that happen. But a mic is too cheap, buddy. Sorry.
Hey, go ahead, Brad.
I actually want to talk about Radeon Super Resolution a little bit more. So that's obviously building off the back of Fidelity FX Super Resolution, which has come out the gate, swinging. You guys already have 40 plus games it's integrated in. The highlight feature of Radeon Super Resolution is that it'll work with virtually every game you can run if you're an AMD owner. But Fidelity FX Super Resolution has to be baked in by the game developers. That has a couple other advantages. I was just wondering if you think they both will Fidelity FX Super Resolution kind of be strangled in the crib because of Radeon Super Resolution, or do you think it'll continue to be adopted at the pace that it has?
No, we expect, and we're seeing it adopted very rapidly, and the momentum continuing. Over the holidays, we announced that we have 70 titles now, both in market. We have about 45 to 50 titles in market, and another 20 to 25 or so that are committed for the first half of 2022. And that's just what we've announced, right? You know, by the time we announce something, you know that there's more that we haven't announced yet, right? So just count on there being more titles coming. You know, it's probably not going to be out of the realm of reason for us to hit 100 titles this year. That would be probably a probable case. The benefit to FSR is because it's built into the game, you really get the best upscaled output coming out of that for a spatial algorithm, right? We know that there's other algorithms that give you higher quality, but for a spatial algorithm, because you put it in the middle of the rendering pipeline, you're upscaling exactly what you want to be upscaled, and you're not upscaling everything you don't want to be upscaled, which may be some graphics in the foreground, for example, your HUD, your chat, your text, all that kind of stuff. That just gets raw upscaled with RSR, and it doesn't with FSR. So if you're a game developer, you say to yourself, wow, FSR is very simple to implement. I could put it exactly where I want it to be, and the quality is the best quality it has to offer can be preserved. And it works across everything. It works across AMD. It works across our competitors' solutions. It works on APUs or mobile CPUs, and it works on desktop graphics, mobile graphics. It works on Xbox. So RSR, while we love it, of course, because it's an AMD only solution, because it's built into our driver, it doesn't work across all of those other products. So the game industry is very, very motivated to continue to adopt FSR and integrate it. And they're not looking at RSR as a replacement in any way.
Okay. Gordon, I interrupted you.
No, it's all right. Hey, Frank, I want to talk about a trend that I saw over, the last year. AMD really had phenomenal amount of gaming laptop wins. Nothing I've ever seen like before, but I noticed most of the gaming laptops didn't get the highest wattage GeForce cards, and I know that's of course you would say by Radeon, but I'm wondering why a lot of those vendors didn't really push high TGP, the highest end TGP parts, when combined with Ryzen. When it felt like there was way more left. There was way more of a cooling budget left in those laptops, because generally I felt, Ryzen 5000 ran pretty cool in laptops. I could just judge that by fan. I'm wondering if you have any insight into why we didn't see the 150, 165 watt TGP parts in most of the gaming laptops for Ryzen, and whether that might change this year.
Yeah. So for those in the audience that don't know, I was on the OEM side for 20 plus years, doing Alienware and XPS notebooks for Dell. So I know a lot about notebook planning cycles, probably too much. So the challenge has been that it's not too different than what happened with Radeon, as we talked about a year ago and 2 years ago. AMD surprised the market with our 4000 series and our 5000 series mobile APUs or CPUs. And it takes years to plan a notebook, especially one from the ground up. And even after you plan your portfolio, you have resource constraints. So think of it this way. You have 100 engineers and they can build you 5 laptops as an OEM and an ODM. You have 2, right? You have OEMs, which are your Dell, your Lenovo, so on and so forth. And then you have behind the OEM, a development partner that in most cases does a lot of the actual raw engineering for these laptops under the supervision and guidance of the OEM. So you have resource constraints across the entire value chain there. Can the OEM handle it? And can the ODM handle it? Well, in an Intel plus NVIDIA only gaming dominated laptop world, you planned your resources accordingly. And you said all 5 of my notebooks with my 100 engineers are going to be this combination of Intel and NVIDIA. Well, out of nowhere comes AMD Ryzen with this incredible CPU, and people are honestly trying to scramble and figure out, how do I take these 5 laptops and these 100 engineers and suddenly get them to go build me 7 laptops or 10 laptops? But I've only got 100 engineers. Maybe I can grow to 120 engineers, but even if you wanted to grow to 500 engineers, they're not out there. They don't exist. We have a resource limitation in the entire industry. We can't hire engineers as fast as we're trying to as an entire industry. So it's just a matter of that, us coming to market surprising folks with an incredible CPU that was outperforming everything that was out there. And them honestly having a laptop portfolio that was already planned, already resourced, already being developed. And a lot of that planning was done 24 or 18 months before you ever see that laptop hit shelves. That's when the planning and the resource locking and everything is done. And then they're trying to scramble to figure out, how do I get AMD in there? Oh, then by the way, it's AMD. Like, I mean, let's be honest, right? Those of you that have been following this for a while, it's AMD. Are people going to really adopt it? Is it really as good as we think it's going to be? They're a value brand back then. Now we're a premium brand, but back then we were a value brand. So as they're doing their planning, they're trying to make the smartest decisions they possibly can for their business because they have those resource constraints. So they're putting what at the time was perceived to be a value branded CPU in with value graphics. And they thought that, other brands would be the only ones that would be able to sell at the ultra high end. The OEMs and the ODMs are partnered with us and bet the other way and put our CPUs with the highest end graphics. They're the ones who did the best over the last year and a half. But I don't blame them. I would have made the same decisions if I were in their shoes because I've been in those situations. It's hard to be a notebook product planner and product manager at these companies. So that's the reality of the situation. Now you're going to see and you did, I think, through the second half of last year, you saw a lot more Ryzen with high-powered NVIDIA graphics and now with Radeon graphics. You're going to pretty much see a 50-50 mix, if not even more, in favor of AMD, just because we've done so well and we've proven ourselves so well with Ryzen in mobile.
And I just have a quick follow-up there because you're saying definitely there was a resource issue and planning. I understand all that, but sometimes I felt like there was a segmentation issue because it's like, my highest margin product is going to be Core i9 with a top end GeForce. I don't want to have my cheaper, lower cost Ryzen based one, frankly, be as fast as my top end Core i9 GeForce product. So I almost felt like we'll put a 130 watt TGP part instead of the 160 because, we want to push them to the laptop that makes us the most money. I'm just wondering.
But all that plays into the resourcing, Gordon. It really does, because even once you design the carcass, which is a whole set of engineering resources that are required, the carcass being the motherboard and the mechanical substructure of the laptop, then you start just plugging parts in. You think, what's the difference between this SKU and that SKU and the other SKU? You have to validate all of that. You have to, every SKU combination is completely validated. And then keep in mind, CPUs and GPUs are soldered onto the motherboards. So that's a whole SKU. And every one of those SKUs adds complexity into the portfolio. You have to forecast it. You have to store service parts. You have to train your tech support team for it. So you have all this complexity that all these teams are trying to manage with constrained resources. And what they're trying to do is reduce their complexity as much as possible so that they can offer the market as much as what they can. And to your point, you're right. There was some segmentation there because AMD perceived as a value brand at the time. And it's just so hard to remember where AMD was 3 years ago to where we are right now, right?
Huge difference.
Try to remember 3 years ago, we were in Chromebooks, and these $400, $500 laptops. You couldn't find an AMD Ryzen CPU in a laptop over $1,000 3 years ago. And we've come immensely far. I mean, it's just incredible how far we've come. But all those resource constraints, it forces them to go into and say, okay, I can only validate, let's say, 3 motherboards of these 5 laptops that are going to be AMD based. They're a value brand. I should probably put them in the lower price point products versus taking this huge risk, putting them at the high end. So it's very honestly, it's quite simply that. It's not anything more complicated than that. Everybody has finite resources and everyone's really trying to make the best decisions they can. And hindsight's 2020 for a lot of these folks, but they're righting the wrongs. I mean, we announced 200 premium laptop designs at CES. That's pretty much the whole market is going to be by and large covered. That's outside of a few exclusives here and there. And then we have our exclusives, our competitors have their exclusives, which is very normal. But we don't have that conversation anymore. That conversation we were struggling with 3 years ago of you should assort us at the high end and that doesn't exist anymore. Everyone's got it. And they've either reduced their SKU count on some of the other competitive offerings, or they've been able to scale up their resources, or they're doing motherboard leverage in different ways. So it's not a problem anymore.
What I find, go ahead, Adam.
I just had a couple quick questions from the chat before we get out of here, if that's okay.
Let me ask my question first.
No, go for it.
So one of the things I find really interesting involving laptops, everything in general, is for a long time, as you know, on the desktops at least, AMD didn't have the best advantage with software, didn't have the best reputation with software. But I think you guys have really stepped up and corrected that over the last few years. I think that you guys are actually starting to set the tone in a lot of ways with smart access memory. We saw Intel and NVIDIA follow along after that with PCIe resizable bar. Smart Shift, I think, was huge for you guys last year, which is part of the reason why they did start seeing the change in adoption. And you guys announced next generation Smart Shift stuff, which works Radeon GPU, Ryzen CPU working together in tandem. You've got a couple new technologies coming out this year. Smart Shift Max, which says offers up to a 2 times increase in performance in some scenarios. And there's also a battery version that, optimizes around battery life. Is it really a 2x increase in performance? That's a pretty sizable claim. Is that going to be as significant as Smart Shift and Smart Access Memory were?
Oh man. Is it real? Yeah, it's absolutely real. We would never lie, and certainly not intentionally in the benchmarks that we showed. Is it practical that you're going to get a 2x uplift on most of your titles with Smart Shift? No, that's not practical. Honest. But it's better. It's Smart Shift 2.0, but we're using the Smart Shift brand for other things like the Eco technology, which shifts between your APU's graphics and your DGPU's graphics. So rather than just calling it 2.0 and then confusing everybody around that and Eco, we went with Max. I don't know if there'll ever be what's better than Max now. I don't know. I hope it's not Ultra because that's so
Ultimate.
Overused. But
Max with 3Xs.
Yeah, right. We'll figure that out later. But yeah, it's just a better version. And what it does is Smart Shift. And the joke I say is that it's smart, but it wasn't smart enough. It shifted the TDP a little bit blindly in that it said, oh, a game is running. Let me shift the TDP very rapidly over to the GPU. Oh, a workload that's more CPU dependent. Let me shift it to the CPU. But in some cases, workloads and applications get bottlenecked if you shift away from the CPU too much or you shift away. And we weren't really monitoring those bottlenecks, and we weren't kind of bilaterally shifting back and forth very rapidly to find the sweet spot. So that's why some applications weren't getting any benefit because we were kind of choking them. And then other applications were getting X amount of benefit, and we were able to extract Y from it because we're smarter now, which is the pun, we're smarter with Smart Shift Max, and we're able to not go guardrail to guardrail on how we're doing the TDP shifting. It's more precise. And it's just more refined, and everything we learned out of Smart Shift 1.0, we built it into 2.0, and that's the benefit we're getting out of it.
Will that be
thank you for the
exclusive?
compliments on the software, by the way. We had a really rough time with drivers in the past, and we've made a commitment about a year and a half, 2 years ago that we were going to put stability and reliability first in our driver decisions. And it slowed down the introduction of new features in terms of quantity of new features. But it's given us the ability to introduce higher quality features that have more of an impact into the user experience. And the driver package has been really, really stable. And I think we've done a fair job of when customers have escalated issues to us, we've really tried to respond to what those issues are that they've escalated to us. I mean, that's a commitment, and it's not easy. Software is so hard, but we're trying really hard, and we appreciate the team's feedback, yours and as well as our end customers, because that's what keeps us honest and keeps us focused on the right priorities.
Everyday quality of life beats quantity of features. These new Smart Shift modes, will they be exclusive to the new laptops coming out, or will they get imported back to some of the existing Smart Shift laptops?
The challenge with these features is they're more than just software. They're really developed and designed in at a low level into the actual chips themselves. So we've worked with Robert's team and then Laura and Scott's teams on the graphics side and the software team. You can't just like patch these things. It's not that simple, unfortunately. I think we do a pretty good job of trying to give backwards compatibility everywhere we can. FSR, AM4, all these different things. It's not possible on most of these things. Like Smart Access graphics, you have to have a MUX. in there. The MUX has to be designed a certain way so that it interfaces with the motherboard, the BIOS, and everything, so that we can software control it. So if it's not designed that specific way, we can't control it through Smart Access graphics. So it's not like we can just patch that onto other MUX designs. Smart Shift Max, the same thing as Smart Shift. It was designed into the Ryzen 6000 series CPUs, like Smart Shift was into the 5000. So you can't just software patch it.
It totally makes sense. I just wasn't clear, so I wanted to be sure.
Yeah. Smart Access Memory, though, that one will continue to scale with PCI Express. We actually are getting a little bit. It was so negligible, it was like 1 to 2%, but we're getting better uplift out of PCI 4 now that we moved to that with Smart Access Memory. We didn't talk about it at the show because it was like, who cares about 1 to 2%? But folks that move over to PCI Gen 4 platform will get a little bit better uplift out of Smart Access Memory as a result.
Thank you. Adam, sorry to distract you.
A couple quick ones. I know there's a ton of questions out there. Thank you, everybody. Rapid fire. Can't get to all of them, but I do have a couple really good ones. Austin23 put on Discord, will AMD be putting out an updated Radeon software feature request survey this year?
We will now.
There you go. Okay, then.
You did it. You did it, Internet. You did it.
Let me write that one down. Go ahead.
Nocturnal 101 Ravenous gave us $5 super chat. Thank you so much. Said, any news on AMD with PCIe support supporting CXL for multi GPU scaling for gaming?
Not likely.
Okay. Peter Jansen had asked, can you explain if license deals block the open sourcing of the firmware for graphics cards? They're a fan of Linux and wondering about getting stuff over there.
The firmware of the graphics card being open sourced. I mean, I always get an open source question when I'm here with you guys. I think the driver now we have it out there as an open source driver, but I don't think we have plans to make the firmware on it open source. When we make open source decisions, it's typically to help drive industry adoption and to help kind of, we have our reasons for why we do what we do under the Fidelity Effects brand of all these tools and everything that are out there. I'd have to hear some good arguments as to why we should go about and do that and why that would be good overall for the entire industry. And we'd have to weigh, I don't know. I'd have to think about that a lot more and have some conversations with folks on that one. But I don't think that's in our plans right now that I know of.
Okay, and last one, in internal Duo gave us $10 or €10 super chat. Thank you. Said, given the recent controversy of vendor locking of pro products to specific vendors, is this something AMD will expand to consumer products, especially when there's a focus industry-wide on reducing e-waste?
What does he mean by that question?
I asked for a follow-up. They said there's been some chatter about Ryzen Pro products being vendor-locked behind companies like Dell, meaning you can't reuse components salvaged from broken PCs. Was their follow-up.
I don't know the answer to that one. But if he wants, hit me up on Twitter with the question at Azor Frank, and I'll follow up on it. I'll ask the team.
Somebody in chat saying he's referring to PSB.
I don't know.
Okay. All right.
I'm sorry.
Sorry about that.
I don't know, but I will follow up on it. If you hit me up on with the question, whoever asked it, I'll follow up on it.
Okay. Awesome.
All right, guys. I really have to run. I'm sorry.
No, thank you.
It's been a pleasure. Always a pleasure. Thank you for the opportunity.
Definitely. I could do this all day with you, but we got to go. Check back tomorrow for your fix of PC Talk on the Full Nerd. For audio listeners, subscribe to us on iTunes, Google Play, Spotify, Stitcher, and please do leave a review. Every time you do, Frank Azor responds to your Twitter request. He'll do that anyway. Send questions and comments to the Full Nerd at PCWorld.com. Thanks for coming. I'm Gordon Ung with Brad Charkis.
Adios.
Frank Azor.
Bye, guys. Thank you.
Robert Halleck, who is left, I'll say bye for him. Bye, Internet. And Patrick Moore's going to hit the house.
Thank you so much for being here, Frank. Thanks for all your great questions. We'll see you later. Bye.